Okay, so you sent over this stuff on path testing and more specifically basis path testing and how it applies to software.
Yeah.
And it seems really interesting. So we are going to take a deep dive into it today.
Okay, sounds good.
Um, so what is it all about, and why is it important in software development?
Well, so path testing, um, it basically means that we're going to look at every possible way that a program could run its code.
Okay.
And by looking at all the paths, we can hopefully find any faults in the program.
Okay, so every possible path that sounds incredibly thorough,
Uh-huh.
but also like super time consuming. I mean, even like a small program could have tons of different routes through the code, right?
Yeah, and that's exactly the problem. For any reasonably sized program, there's just way too many paths to test them all. So it's just not practical to test every single path.
Okay.
And that is where basis path testing comes in.
Okay.
It's a type of white box testing, and we call it white box testing because we're looking at the internal structure of the code instead of just treating it like a black box.
Right.
So in basis path testing, instead of testing all the paths, we pick a smaller set of paths to test.
Okay, so what makes these paths special? Are they just random or?
Yeah, so these are not random paths.
Okay.
They're special because they're independent of each other, and any other path through the program can be represented as some combination of these paths.
So it's like we're testing these key routes, and by doing that, we're kind of indirectly covering all the other possible execution scenarios.
Exactly.
Okay, I think I'm starting to get it. So the material you sent over included a nice little example of how these paths actually look, and this was illustrated with a control flow graph and some code.
Yeah.
And the graph showed that there were 3 different paths, and these paths were 1, 2, 3, 5, 6, 7,
Right.
1, 2, 4, 5, 6, 7,
Yep.
and 1, 6, 7.
Mm-hmm.
And these different paths happen depending on whether certain conditions in the code are met, and that sort of sends the execution down a different sequence of steps.
You know, what's really interesting about software is how just a small change in the input can result in a huge change in how the program actually executes.
Okay.
So it's really important to make sure that we've tested all the critical journeys through the software.
So we've talked about like what basis path testing is and why it's important, but
Yeah.
how do we actually do it? Like how do we go about performing basis path testing?
Yeah, so there are a few key steps that we need to follow.
Okay.
The first step is to create a control flow graph of the program.
Okay. And what exactly is a control flow graph?
So a control flow graph is basically a visual representation of the program.
Okay.
So different parts of the program are represented as nodes in the graph.
Okay.
And the possible transitions between those different parts of the program are represented as edges in the graph.
So it's basically like a map of the program.
Exactly like a map of the program.
Okay, cool.
Once we have the control flow graph, the next step is to calculate the cyclomatic complexity of the program.
Cyclomatic complexity.
Yeah, so cyclomatic complexity is basically a metric that tells us the minimum number of paths that we need to test
Okay.
in order to ensure that we've tested every part of the program.
So it gives us a number of paths to aim for.
Right.
Okay.
So once we've calculated the cyclomatic complexity, the next step is to find a set of independent paths that correspond to that complexity.
Okay.
And then finally, we need to create test cases for each path.
Okay, so we've got our control flow graph, we've got our cyclomatic complexity, we've got our set of paths, and we've got our test cases.
Right.
Now, what are some of the benefits of using basis path testing?
Yeah, so there are several key benefits to basis path testing.
Okay.
One is that it can help us to reduce the number of tests that we need to run.
Okay.
Because we're not testing every single path, we're just testing a smaller set of paths that are representative of all the paths.
That makes sense.
The second benefit is that it helps us to focus our attention on the program's logic.
Okay.
Because we're thinking about the different paths that the program can take, right? The third benefit is that it can help us to create more analytical test cases.
Okay.
Because we're not just randomly testing the program. We're thinking about the different ways that the program can be executed, and we're creating test cases that are designed to test those specific ways.
So it sounds like basis path testing can make our testing a lot more efficient and effective.
Yeah, that's exactly right.
So to recap for you out there,
Okay.
the first step is drawing the control graph, then calculating the cyclomatic complexity, then finding a set of paths, and then creating test cases for each path. And this helps reduce the number of tests needed.
Right.
It helps us focus on the program's logic.
Right.
It helps us create more analytical test cases.
Yeah.
And most importantly, it helps us determine faults within our code.
Exactly.
So that's basis path testing in a nutshell.
Yeah.
Now think about this. How might thinking about the different execution paths in your code lead to more effective and efficient testing strategies in any project you might encounter? That's something to think about.
Yeah.
Thanks for listening.
Thanks for having me.